Go.
So we talked about the acid rain and global warming.
And we're talking about how it's changing our Earth. So, how it's changing Earth.
And how this program related to those things.
Nice and loud.
So this is our atmosphere. This is the breakdown of the gases that are currently present. Most people don't know this, but nitrogen is actually the gas that is present in the greatest quantity. 78% of our atmosphere is nitrogen gas, which is N2. The next highest is oxygen, which is 21%. And then this tiny fraction right here is actually, is all of these gases. So we have argon, which is 1%, carbon dioxide, which is 0 to 3%. And the other gases are 0 to 0.02%. They're known as trace gases because they're very, very small quantities.
Here's just a breakdown of the gases. Nitrogen and oxygen are obviously in abundance, and then water vapor is also a variable component, so it ranges from 0 to 3%.
So now we're going to talk about the greenhouse effect. Greenhouse gases consist mainly of water, carbon dioxide, and methane. And what happens is we have so many CO2 emissions that it tends to trap the heat in, and it's starting to warm up our Earth. And it's making the ice melt in the North and South poles, which is causing the sea levels to rise. It's also starting stronger and more longer wildfires. And it's also causing some animals to migrate, and some species who do better in the warm weather are thriving, while others that have been in cold weather are struggling.
So this is Earth's energy budget. This is basically telling us where the solar radiation goes. So 23% of it is absorbed in the atmosphere by the gases there. 48% is absorbed at the surface by animals and plants. And then 29% is reflected off of the clouds. And this is where the greenhouse effect also comes into play, because larger amounts of the radiation that is coming to Earth is getting trapped in by the greenhouse gases, subsequently raising the temperature of Earth. So this is something that Dr. Druckenrod talked about, which was very interesting to all of us, I think. So this is showing the atmospheric carbon dioxide concentration in parts per million. And so in 1720, we're at around 275 parts per million. And the projections for 2020 show that it's at around 400 parts per million. Now, the thing that raises concern is that it took 200 years for the concentration to rise from 200 parts per million to 400 parts per million. But by the time our generation dies, it will be at 600 parts per million. So as you can tell, it's an exponential growth curve. And that's concerning because global warming is rapidly increasing, and we should definitely take steps to limit our carbon dioxide emissions.
And also, carbon dioxide is a trace gas. It only makes up around, well, right now, around 0.04% of our atmosphere. And even this little percentage increase has a major effect on our Earth, our environment.
So going from 0.04% to 0.06% has drastic consequences.
So there are many ways that we can slow down climate change, but like one way that I can talk about, when we visited the Stony Brook watershed, they took steps to build sustainable and eco-friendly buildings. Some ways that we can do this is by building solar panels. They also had geothermal heating and cooling. What happens is the water circulates through 400 feet deep pipes, and a heat pump forces the heat to the ground. And they also have green roofs, which store plant water and reduces stormwater runoff.
Yeah, so when we were at Stony Brook, we actually went to the stream there, and we were testing all of these characteristics of the water, so the pH, salinity, temperature, and so on and so forth, and seeing if that water was good enough for the three types of the marine creatures that would live there, which are tolerative, sensitive, and very sensitive, which they had them categorized into at